Alright guys, welcome back. Today we're going to be looking at day 2 of angle relationships, and we have some more vocabulary words. So our first vocabulary word is perpendicular lines. So perpendicular lines intersect to form 4 right angles. They intersect and are congruent and also adjacent. There are segments and rays that can be perpendicular, or parts of other line segments and rays. The right angle symbol indicates that they are perpendicular. Okay, so over here we have this picture right here. This red looks like a half of a square. That indicates that that is indeed a 90-degree angle, which means that AB would be perpendicular to CD. We indicate in geometry perpendicular with an upside down T, and it's, you would say it in English, it is perpendicular too. So an example here, we have line AB is perpendicular to line CD. Okay, so in that case we are going to use some things about being perpendicular and some algebra to solve problems. So it asks us to find x and y so that KO and HM are indeed perpendicular. So we have to figure out where our lines are here. So first of all, let's find line HM, which is here. And we are going to find line KO, which is right here. So if that is true, then this angle, I'm going to show you right here, this angle right here should make a 90-degree angle. So what I notice here is that I have two parts. I have this angle here and I have this angle here. So what I can do is use the following mathematical sentence to prove what the value of x is. So I'm going to say 3x plus 6 plus 9x is equal to 90. Definition of being a right angle is at 90 degrees. So we would solve combine like terms. 12x is equal to 90. Subtract 6 from both sides. We get 12x equaling 84. And then finally we would divide both sides by 12. And I'm going to press pause and get a calculator. Okay, took the calculator out and I got x equaling 7. So always with geometry we have to figure out if we've answered the question. So let's go back up to the question and see what it says. Find x and y. So if x is 7 and we want to solve then for y. So what we're going to do here is, if that is a right angle, then this would be a right angle. So what I need to do then is to prove that that is equal to 90 degrees as well. So we get 3y plus 6 equals 90. We follow the same process, subtract 6 from both sides, and we get 84 again, and then 84. Now if they would have asked us to find a different angle, we might need to plug in x or y, but in this case they're just wanting us to get the value of 90 degrees. So here's another one. I'd like you to press pause and see if you can answer this question, and then when we come back we will check out the answer. Alright, here we go on to the next problem. So check, we were trying to see if we could figure out the value of x so that they are perpendicular, so we get an answer of 9. So here we have some things that we need to talk about in geometry. So oftentimes in geometry things are not drawn to scale. So you cannot make assumptions just because it looks a certain way or you think it is that way. It has to be proven. So things that can be shown. Here we have all points shown are coplanar. They're in the same line. G, H, and J are collinear. We have lines HM, HL, HK intersect. We can say H is between. I can say also that L is in the interior. That also that G HM and MHL are adjacent, and that angle GHL, LJH are linear pairs, and we can also make a statement that JHK and KHG are supplementary. The following things on this side cannot be proven. So here we have line HM. Here's line HM. We cannot necessarily say that these two are perpendicular because we just don't have enough information. There would have to be that symbol in the corner that indicates they're a right angle. So you'd have to have one of these in the corner. We can also say that, we can't say that angle JHK, so JHK, that's this angle here, we cannot say that that angle is going to be congruent to this angle. We cannot just assume that those are congruent. And then you can just go on and all the other little things here that we cannot prove because there isn't any markings. There would have to be markings on the graph to indicate those things. So we have two questions left. The first is to determine whether the statements can be justified based on the picture below. So we have to look. Here we find angle VYT. So what I notice here is VYT is also being formed by, I'll change my colors here, these two intersecting lines. And I do have this information right here that that's a right angle. So if that's a right angle, then all of these also are right angles. That was the definition of the previous page. So can we truly prove that VYT is 90 degrees? The answer would be yes. Alright. Part B. I'm going to erase this. Part B. We want to know if we have enough information to prove they are supplementary. Supplementary means when you put them together, they're going to equal 180 degrees. So we start with T, Y, W, and we have T, Y, U. So yes, because they form a straight line right here. And the next one, adjacent angles, so we'll choose a different color here. So I have V, Y, so V, Y, W, and T, Y, S. Well, unfortunately, they have two non-common sides. I'm going to show you the non-common sides, which is one of the qualifications, but they don't share a common side. And so for this case, it would be no, because they don't have a common ray between them. Okay, so I'd like you to just go ahead and try this one, and then we'll come together and just see if you got the answers. Alright, so for sure the first one is a no, because we would have to have some markings in here that would prove that this right here is a right angle, and we do not know that. So let's move on to the next one. We have these two angles. Determine whether they are complementary. We cannot prove anything about that.